Greetings. A cubical block of side 0.5 meter floats on water with 30% of its volume underwater. What is the maximum weight that can be put on the block without fully submerging it under the water? Okay, so the question is very simple. First thing what he is telling, a cubical block of side 0.5 meters. Okay, it is having a length of 0.5 meters. Floats on water with the 30% of its volume under the water. So 30% of its volume is under the water. What is the maximum weight that can be put on the block without fully submerging it under the water? So maximum weight that can be put on the block so that it can fully submerge into the water. So what are the things that we can do? What is the maximum thing we can put on them so that it will be fully submerged? So let us see. Fully submergement, it should not sink. It only completes the things like that. Okay. So means only up to this error it can be things. Here the things they have given are the block side is 0.05. Okay. It is initially 30%. 30%. It is initially submerged. So let us check with the things. What are the key concepts? The key concept is very simple. Whenever any block or any object, solid object, if it is immersed in a full-fledged container liquids, then the water will spill out of it. Am I right? How much of water will spill off it according to Archimedes principle? Whatever the volume of the cube or whatever the volume of the block or whatever the volume of the stone, that much of amount will be spilled out of the water container. Therefore, the amount of water, whatever spilled, okay, using the formula rho g, okay, rho vg, we can calculate the weight of that object. So, using the buoyancy theorem, when it is fully submerged, means without completely sinking, it is just floating, but it is fully submerged, then the weight of the block W is equal to rho density of the water into volume of the block into gravitation g. Therefore, that is equal to density of water is here has given it as 10 to the power of 3 kg per meter cube. Okay, this is what they have given. Therefore, density is 10 to the power of 3 into volume of the cube block. So, volume of the block is 0.5 whole cube into 10. Since they have not given anything, I am just doing the approximation. Therefore, finally, I will have 10 cube into 0.125 into 10. That is nothing but 1250 kg, whatever it is, okay, Newton of force we are getting. But this force contains block's mass, okay, plus block's mass plus extra weight what we have put on the block for the sinking. So both of them will be there. So now to overcome this, okay, first we have to find ಇಲ್ಲಿ ನಮಗೆ ಕೇಳ್ತಾ question ಏನು, he is asking us only to find what is the maximum weight that we can put on the block so that it won't sink. It won't sink completely. So maximum weight that we can put so that it won't be sink. So first we should identify what is the block's mass. So already we know that block plus the mass, whatever extra add-on we are putting together, it is giving me 1250 Newton. Now I have to find what is this extra, what is the block mass. If we get the block's mass, then definitely we'll get the extra mass, whatever we have put on the block. So in order to calculate the block's mass, okay, what I am doing is, so we know that only 30% of it is sinking into the liquid. Here it has given initially it has been sink at only 30%. That is 30 by 100, okay, of the mass is sinking into the block. Am I right? That is only 3 by 10th of the block is sinking into it. 3 by 10th of the block is sinking into it. As usual, we know that from Archimedes principle, density of the block into volume of the block into G must and should be equal to same formula, density of water into volume of the water. How much of volume of the block is sinking here? Only 3 by 10th of the volume of the block into G. Only that much is sinking here, means only that much is inserted into the fluid. Gg gets cancelled, Vb gets cancelled. Therefore, density of the block is equal to 10 to the power of 3 into 3 by 10. So for already we know that 3 by 10 to the power of 3 is 1000. On simplifying this, we'll get density of the block is 3000 kg per meter cube. Once we get the 3000 kg per meter cube, calculating the mass of the block is not a big issue, because mass of the block is equal to density of the block into volume of the block. Density of the block is 300 into volume of the block. How much we have here? Okay, the total block is 0.125. On simplifying this, we have approximately 375 Newton is the total kg. So 375, 37.5 kg. Okay, here also, since it is a mg is the force, he is asking extra weight only. Okay, since he is asking extra weight, therefore this will become, since he is asking extra weight, therefore it becomes the weight of the block, purely block, is 375 newtons. Therefore, the extra weight, total weight is equal to weight of the block plus the extra weight that we have put on the block. Therefore, extra weight is equal to weight minus weight of the block. That is equal to weight is 1250 minus 375. So on simplifying this, think we get approximately 875 Newton. We'll check the options. In options, we don't have 875 Newton, but we have 875 kg. So divided by 10, we'll get 875 kg. So option B is the right answer. I hope you understood the things. Thank you.